So the other day we talked about like terms, right? And we said that like terms, they must have the same variables and the same exponent. Do you guys remember that? Right? We talked about it's like same as apples. They have to have the same features. So galas, I say I have 5 gala, right? So same with terms. In order for them to be like terms, they have to have letter and the same exponent. So if I have 2x to the power of 5, can you give me a like term to 2x to the power of 5? What is it? 3x to the power of 5. Okay? So in this case, I can say these are like terms because they have the same letter and they have the same exponent. Okay? Can you give me a like term to negative 7xy?
Negative 3xy.
Could it be 3xy?
Yeah.
Sure. Okay? The coefficient, which is the number that precedes the variable, can be anything. Okay? And then as long as you have the same letter and the same exponent. Okay? Why do I need like terms? Because I can simplify. I can add and subtract like terms. Okay? So remember, if I have 2 gala plus 7 gala, that gives me 9 gala. Okay? I can add them. I can add the coefficient, what we call the coefficient. Okay? So if I have a plus here, right, I can add 2x to the power of 5 plus 3x to the power of 5, and that would give me 5x to the power of 5. Okay? So you add your coefficient. So when you're collecting like terms, you're adding or subtracting the coefficient. So remember, coefficient is the number that comes before the variable of terms that have the same variable and exponent. Okay? It's at the back. Just keep. So if I have 2a plus 3a, can I add these coefficients? So 2a plus 3a. So that gives me what? 5a. Okay? So if I have the first example, I have 3a minus 2b minus 5a plus b. How can I simplify this? So what's 3a minus 5a? Positive 2a or negative 2a? Negative 2a. Okay. Then?
Please report to the main office. Desired to the main office. Thank you.
So I have negative 2b plus b. Positive or negative? Positive or negative? Negative. So that's going to be minus b, right? Do I need to write 1b? No. So it's the same thing as I told you before. If I say 1 apple or an apple, it's the same idea. It's the same thing. Okay? So I remember, if there's nothing in front of it, that means it's a 1. Can I simplify this any more? Any further? No. Okay? So I have to leave it like this. All right, so for this one, remember, whenever I'm simplifying, I want the equal sign to be at the beginning of your new line. Okay? So you see how I scratched that equal sign from the end here? I don't want it here. I want it at the beginning of the new line. So how can I simplify this one? Where are my like terms? So 2x squared minus 4x squared. So I have 2x squared, and I'm taking away 4x squared. What do I get? Minus 2x squared. Okay? Now, where are my other like terms? So I have the 3x and the 5x, which gives me plus 8x. And then the negative 6 plus 7, right? These are your constants, okay? You can add them together, so that gives you plus 1. Am I done? Yes, because I don't have any more like terms to collect, okay? Okay. Here's some terminology that I want you to remember because I'm going to be saying this terminology. Josiah. No. You have to learn the graphing by yourself. After that. Okay. Now, when we're talking about polynomials, okay, so here new term you guys, okay? So we have a term by itself is called a term, or we can call it a monomial, okay? So a term, one term, is called monomial. Okay? If I have two terms added or subtracted, so like I did here, so in this case I have two terms, negative 2a minus b, okay? If I have two terms, we call that binomial. Okay? And if I have three terms, it's called trinomial. Okay? So one term, monomial, two terms, binomial, three terms, trinomial. You're going to hear me say these words. You need to know what I'm referring to. Okay? Now, anything over three terms, we call it a polynomial. They're all the polynomial. Anything over one term is a polynomial, but there are specific names for them. But anything over four terms, we don't specify anymore, and we call them, so four terms or more, I should say. We just say polynomial. I think it's with a Y. Okay? We're going to learn something very important, and you're going to use that all the time. Okay? First thing, it's called the distributive property. Okay? It's called the distributive property because you're distributing something into something else. All right? So here's a question for you, and I usually use that example in all my classes. So if you've heard it before. If you went to a Taco Bell, okay, and then they have a combo which is 2 tacos and a pop. Okay, so this is your combo. You're a family of 3. Okay, so you have 2 tacos and a pop per combo, and you're a family of 3, and you want to get 3 combos. Okay, so you want to get 3 combos. How many tacos are you going to get, and how many pops are you going to get? 6 tacos and 3 pops. Right? So what did we do? We multiplied this by 3. Right? So I multiplied that 3 by my combo. So I multiplied the 3 by the 2. And I multiplied the 3 by the 1. You just did distributive property. So you just followed what I'm going to show you. So if I have something here outside multiplied by, we call this a monomial because it's one term, right? Multiplied by a binomial, 2 terms. All what you have to do is you have to multiply the monomial by the first term, and you have to multiply the monomial by the second term, right? Did I just do that with the taco question? What do we call this? We call it the distributive property. Okay? Or rainbow. So, multiply each term of the binomial by the monomial. Okay? So, A times B is AB. A times C is AC. So I have AB plus AC. Are they like terms, AB plus AC? No, because they don't have the same letter, do they? The first one is A and B, the second one is A and C. Are they like terms? No. Okay? Let's look at the next example. Okay? So I have negative 2a multiplied by 3a minus 2b. Negative 6a what? Okay, I'm going to erase that equal from here. I'm going to put it here. So that's negative 6. And then a times a is a squared. Okay, here's where I want you to be careful, guys. We are multiplying. Okay? Multiply, you multiply the number by the number, the letter by the letter. I don't usually write negative 6AA. Doesn't make sense that I write AA because there is a simpler form, right? Which is a squared, okay, to the power of 2. Okay? And then if I multiply negative 2a by negative 2b, negative and negative makes a positive. 2 times 2 is 4. A times b is ab. Can I simplify this? That's it. Okay? This is the most simple form because these are not like term. You can't do anything with this. Okay? Are we okay with this? Let's do another example here. How do you multiply that? Negative 12, because 3 times negative 4 is negative 12. X squared, because x times x. Okay? Yeah. Plus 3xy. What's the coefficient here for y? 1, right? 3 times 1 is 3. And then x times y is xy. Are we okay with this? Everyone? Brackets are jail for your terms. You have to release them from their jail before they can combine with other terms. Okay? So, whenever you have brackets, you want to get rid of these brackets by simplifying, by either distributive property or by just, you can't just remove the brackets because you feel like it. You have to follow the distributive property all the time. Okay? So if I'm looking at this, what are you thinking when you're seeing something like this? 2x minus bracket, x minus 8y, close bracket, minus 3y. If I want to simplify this, what do I have to do? Collect the like terms. I can and I should. I should collect like terms. But can I do it because I have brackets? Unless my terms inside the bracket are like terms, then I can do that, but they're not. X and Y, they're not like terms. So I can't collect like terms because I have a bracket. So the first thing I want to do is release these terms from the jail. Okay? So how do I release these two terms from the jail? That 2x is not multiplied by this. Right? This 2x is not multiplied by this, is it? Eyes on me, this is very important. A lot of people get this wrong. What am I multiplying that bracket with? Negative, which is a negative 1. Okay? It's an invisible 1. Okay? That 2x is just there, and it's subtracted by this. Okay? So I have 2x. That negative 1 is going to multiply by the x. What does that give me? Minus x. And then when I multiply this by this, what do I get? Plus 8y. And then minus 3y. This is just subtracted, okay? Nothing's happening to that one. Now I can collect like terms. So 2x minus x. And then 8y minus 3y. And I'm done. Okay, so you have to be careful of what is the operation, what is happening. So this is the simple one if I have a monomial multiplied by a binomial. Okay, what if I have a binomial multiplied by a binomial? Okay, so what if I have a term multiplied by two terms? How can I simplify that? How can I expand and simplify?
You do the like terms first. Combine like with like.
If we're inside the bracket,
No. Outside the bracket. So
I can't do that because I have the brackets. So I can't just I can't just add these because there is a multiplication here. Okay.
A multiplied to C first, and then A multiplied to B,
Mm-hmm.
then B multiplied to C, and B multiplied to D.
So I have the distributive property twice here. Okay, eyes on me. So you're going to pretend that this is multiplied by C and by D, and you're going to do the distributive property for that first. And on top of it, this is multiplied by this, and this is multiplied by this. So instead of having only one term multiplied by the two, you have two terms multiplied by the two. Okay? So we call this, the process here is called, or the acronym for it is FOIL, which is first, outer, inner, last. Okay? So you're going to hear me say the FOIL method. Okay? This is what I mean by the FOIL method. Okay? So you multiply the first terms in each bracket together. So if I look at my first terms here, my first term in the first bracket is A. My first term in the second bracket is C, right? So A times C gives me AC. So this is my first. Then my outer terms. So if you're looking at this, what would you say your outer terms are? So where are your outer terms? A and D. Okay? So these are your outside terms. Then I stands for inner terms. So what are your inner terms? The inside. B and C, right? Because these are your inside terms. And then last. So the last term in each bracket, so that's B and D. So this is where the acronym FOIL comes from. First, outer, inner, last. Okay? So you see that from the first one, you have 2 arrows coming out. From the second term in the first bracket, you have 2 arrows coming out. Now, usually when I do this, I have like terms that I can collect. In this case, I don't have any, but usually you'll see that we might have like terms that we can collect. Okay? So let's look at this example. Okay, so where are my first terms? So 2a and negative 3a, so that gives me what? 6a squared, because a times a is a squared. Outer, what are my outer terms? 2a and negative 2b, so that gives me negative 4ab. Okay? What are my inner terms? So what's 4b times negative 3a? Doesn't matter if I write BA or AB. So 2 times 3 and 3 times 2, they're not the same. What's 2 times 3? What's 3 times 2? What's 5 times 2? What's 2 times 5? So does it matter which way I multiply, if I multiply A times B or B times A? No. Okay? So can I write it as AB instead of BA, just so you see that I have like terms? So if I write it AB or BA, it's the same thing. Okay, that's what I'm trying to say to you guys. Okay, what would be my next multiplication? My last terms. What are my last terms? So 4b times negative 2b, negative 8b squared. Okay, looking at these 4 terms, or the polynomial that you see right there, do you have any like terms? Yes. What are they? Negative 4ab and negative 12ab, correct. So what can I do with these like terms? Add. So the first term is going to stay the same. It's not going to change. If I add these two, that's going to give me negative 16ab, because you're negative 4 below the ground and you're going down 12 again. Okay, so you're adding a more negative, and then negative 8b squared. And I'm done. There's nothing else I can do with this. Okay? What I did here is I multiplied 2 binomial. We call that expanding. Okay? We're expanding. I want you to try that second, the last one, the next one, whatever. Okay? You don't need any of this. But you'll probably be doing this later. Yeah. So if I'm going to multiply or expand this, what do I do? What am I multiplying first? My first terms, which are?
2x squared times 3x.
Good. So that gives me, okay, here's the thing. 6x what? Yep, cubed. That's right. Because look here. X squared times another x. Okay? So x squared is already x and x. Right? That's what x squared is. And then I'm multiplying another x. So I have 3 x's multiplied together. So that right away makes it into x cubed. Okay, instead of writing x, I write x cubed. That reminded me of a movie. All right. And then, what do I multiply next?
2x squared
Mm-hmm.
with the 5 plus 5,
So that gives me
10x squared.
the negative x with the 3x. Yeah. So what does that give me?
So then you get 2x squared. No,
You're multiplying. Negative 3x squared. Right? So because you have negative 1 times 3, that's negative 3x squared. Remember, you're multiplying. And then, so that's negative 5x. So now I have to collect like terms. Do you see any like terms? What are they? Yeah, so the 10x squared minus 3x squared. In this case, now I am adding, right, or subtracting. So that will be 6x cubed. Nothing happens to this one. If I add these two terms, that's going to give me 7x squared. And then minus 5x. Just leave it like this. Okay? No, we can't because you don't have like terms anymore. Okay? All right? So, here's the thing. What we have, let's see, what do we have here? Well, the solving linear equation algebraically, I'll do that tomorrow, okay? Because that's another huge lesson by itself, okay? Today, we're going to stop right here, which is expanding. You'll see a lot of this again in grade 11. So make sure that you do the practices as much as you can. So if I can get you guys to do that page that comes right after the lesson, okay? This page, so question 1, 2, and 3, that would be great, okay? Along with the rounding worksheet.